Hello, this is Mr. Win again, and I'm going to go over arithmetic sequences, what we do, the types of rules, and what they are. Well, arithmetic sequences are just patterns where the difference between consecutive terms are constant. That means there's a pattern, like say if I start here with one apple, and I add two apples every time, so I would have one apple, then I would have 3, 5, 7, so on, right? There's that pattern. I'm always adding two. So the example here, if you notice, right, the pattern starts at 1. I'm adding, looks like 3 every time, right? 3 is 4. 4 plus 3 is 7. Plus 3 is 10. Plus 3 is 13. Right, I'm adding 3. There's that constant. The difference between those is always constant. It's always adding by a certain number. Right? Now, there are two types of rules to this. Okay? The first rule is the recursive rule. The recursive rule tells you how to find the next term when you're given the first term. So this is what the rule looks like. All right, it'll usually say a of n minus 1. Usually be some rule here, and then it says a1 and something. Okay, that's always what the recursive rule looks like. What it's saying that is, I'm going to highlight this here, is that you're gonna only add 2, right, to your previous number. That's what that n minus 1 means. But really, the only thing you got to focus on is what's happening at the end there. I'm just adding 2 every time. And then it says a of 1. Now think of 1 as being like the first term, the first number is 12. Okay? So our pattern would start at 12. Notice how I started at 12. And then I am adding 2 because it says plus 2 there every time. 12 plus 2, 14. 14 plus 2, 16. 16 plus 2, 18. 18 plus 2, 20. And I can even keep going on, right? Plus 2 is 22. Plus 2, 24. And so on, right? It's that pattern. It's going to keep adding on. So I'm finding the next number, right? What that rule is kind of saying is if I go back the previous number, I add 2 to it, that's my new number. Right? That's the recursive rule. Explicit rule says I'm going to find any term, and you can plug in n, where n stands for the position of that number. So if I wanted to find the, like say, the 5th number in that pattern, I would plug a 5 in for where n is. And so if I want to find the 10th, I'd plug a 10 in. So in this case, here's my function, right? 2n plus 1. I'm going to try to find the 3rd term. That means I'm going to plug in the 3 for the n. So my function would look something like this. Let's see. Switch back the colors. Well, here we go. So the equation was 2. And then instead of n, I'm going to put in 3 for the 3rd term I'm trying to find out. And then I'm going to add 1, just the equation, and I can do the math there. Well, 2 times 3 is 6. 6 plus 1, 7. All right? If I want to find the 10th number of that pattern, well, same thing. Instead of writing the n, I'm going to write a 10, right? And then just solve it out. 2 times 10 is 20. 20 plus 1, 21. So the 10th term of that pattern would be 21. So basically what I figured out was, here's the 1st, 2nd, 3rd. That's what I found out was 7. I don't have to find out every single number. I could kind of pinpoint which position I want to find out. 3rd, here's the 4th, 5th, 6th, 7th, 8, 9, 10. So that pattern will be 21. And I'm finding certain positions, right? I'm plugging in n for whatever position I wanted to find out. It could even work for like the millionth position if I wanted. I'll just have to plug a million in where the n is. Okay? Let's do an example. What if I give you this equation, right? This is an explicit rule, right? Because it doesn't have the whole n minus 1, and then at the end it says where a1. It doesn't have all that. So we know this is an explicit rule. So if I wanted to ask you, what was the, let's say, the 5th term? Okay? What's the 5th term? Right? All I got to do is instead of writing n, I'm going to put a 5 where the n is. So our function, right, I'm going to figure out for 5. And instead of n, let's put a 5. And then minus 3. What would that give us? The 5th term would be 5 minus 3. It would be 2. But what if I asked you this? All right? I wanted to find, when does that equation equal the value of, let's say, 14? Right? When would it be 14? So I know the value has to be 14, right? When does it equal 14? So the equation would be n minus 3. So when does that equation equal 14? Well, just solve for n, find out what position that would be. In this case, I just need to get the n alone, so let's just add 3 to both sides, right? And then the n will be alone. Well, what's 14 plus 3? 17. N equals 17. That means at the 17th position, the 17th turn, right, is when your n, or when your value, right, that number, that term number would be 14. Okay, so it could ask you either way, all right? It could ask you to find the term number, or it could even ask you to find when will this number appear, right? What position, what term order would this number appear, like the 14, well, the 17th term. You would just solve for n, right? Okay, what if I give you a recursive rule? All right, we know it's recursive rule because two things, right? There's an n minus 1, and it also tells you what your first term is, okay? It doesn't quite look like the one from the beginning, like that an and then the a1, right? But we know because of that n minus 1 and the f of 1 that this is a recursive rule, right? So in this case, let's just figure out this pattern. There's always a couple key information, all right? It always tells you how it's changing, and it always tells you where it starts. So I'm going to start at -6, and then what it says to do is subtract 3 every time. So -6 minus 3, -9, right? Keep subtracting 3. -9 minus 3, well, what would that be? -12. And so on. I can keep going with this. I'm finding the next term every time. So it's not like the explicit where I plug in a number, I get that answer, right? This, I do have to go step by step. And of course, that could be beneficial knowing, right, writing all that set of numbers. So if I can keep going, right, -3, -15, right, and so on, -3, -18, -21, and so on. I'm always subtracting 3. Subtracting 3. That's our order, that's our pair, that's our pattern. That's what the recursive rule is for. All right, and that's it for arithmetic sequences. Thank you.